Hey there, educator, and welcome back to the Make Math Happen podcast. I'm your host, Lanisha, and this episode closes out our month on understanding math. I want to use this time to zoom out and talk about what all of this work and all of these episodes are really doing. What am I really doing here? We've spent the month talking about rational numbers, which included us discussing distance, value, fractions, and decimals. On the surface, it may seem like we've been focused on numbers. And in a way, we are talking about numbers, but we're really going a little bit deeper. And this work didn't start in January. In December, we began by seeing math. We focused on geometry as the visual foundation of mathematical understanding. We talked about how students learn to notice structure, reason about space, interpret movement, and make sense of relationships before symbols ever appear. Geometry helps us slow down and ask, what is happening here? What stays the same? What's changing? Those questions didn't disappear when we moved into January. They simply changed form. When students reason about distance on a number line, they're using the same spatial thinking they used when they compared shapes. When they compare fractions or decimals, they're relying on magnitude and placement, just like they did when analyzing area or scale. When they make sense of division or negative numbers, they're reasoning about movement, direction, and relative position. The same ideas we explored through transformation. So while January may look like a shift towards simply number systems, it's actually a continuation of the same story. December helps students see the relationships. January is asking them to understand those relationships numerically. Geometry gave students a way to organize information visually. Number sense gives them a way to organize it quantitatively. Together, they build the foundation for mathematical literacy. This is why I had to slow down, because before students can connect quantities through ratios, represent relationships algebraically, or reason about change in functions, they need to understand what numbers mean, how they relate to one another, and where they live. This month wasn't about covering content. It was about building coherence. And that coherence is what makes transfer possible. One of the most important realizations that I've had over time is that geometry and number sense develop together. Geometry teaches those students how to see the structure. Number sense teaches students how to reason about value. When students work with number lines, they're doing both at the same time. A number line is geometric. It's a line with direction, scale, and infinite points, but it's also numerical. It organizes value, it shows distance, and it represents relationships. When students truly understand how a line works, they begin to understand that there are infinitely many numbers between any two values. That idea isn't remembered from being told. That idea isn't retained or transferred from being told. It comes from seeing and working with the representation over time. This is why geometry belongs at the beginning of the story and why number systems must be treated as more than skills to cover. Here's something we don't say out loud enough. Understanding takes time, and we have to be okay with that time. We can't tell students everything. Yes, there are things students need to be told. Vocabulary matters. Representations need to be modeled. Ways of thinking need to be introduced. But there are far more things that students need to make sense of for themselves. If we rush that process, we don't get understanding, we get compliance. And compliance doesn't transfer, at least not long term. There's a lot of tension in math education around explicit instruction versus problem based learning. And right now, I sit firmly in the space of carefully guided instruction. I believe there are ways of thinking that students need to be taught. Students need to be taught how to use number lines. They need to be taught how to interpret distance and direction. They need to be taught how to attend to structure and reason about relationships. But after that modeling, they need time to practice those ways of thinking. And then they need space to make connections on their own. That's where understanding grows. I don't know if I'll ever agree with lecturing as a primary mode of instruction in a K 12 classroom. For me, it will always be intentional guidance. We're not filling students with information. We are sharpening their lens so they can see for themselves why the mathematics works. This stance isn't just philosophical, it's supported by research. And I know how people can get about research, right? We can research anything and everything. Where's the evidence? Like, there's a lot of conversation, there's a lot of doubts. We have some work going on from the science of math and position statements from organizations like the National Council of Supervisors of Mathematics. And they emphasize the importance of developing mathematical reasoning, not just procedural fluency. So, research consistently shows that students learn best when they are explicitly taught representations and strategies. They are given opportunities to reason and explain. They engage with problems that require sense making. They are supported in making connections across ideas. This is not an either or approach. It's a both and. It's a both and. When number sense transfers, it shows up everywhere. Students use benchmark values to reason about ratios. They recognize proportional relationships without needing a formula first. They interpret slope as a rate of change, not just a calculation. They make sense of equations by thinking about balance and value. Transfer happens when students understand relationships, not just steps. And that understanding is built intentionally. It's built over time. It's built through representations. It's built through discussion, and it's built through reflection, both on our part and the students, to be honest with you. This kind of instruction doesn't always feel efficient, okay? Especially if our mind is set on speed. This instruction can feel slower. It can feel messier. It can feel less predictable, but it produces students who can think. And thinking is what students need as the mathematics becomes more complex. When we invest in geometry and number sense early and often, we're not delaying rigor, we're building capacity. Ask yourself one question as you plan your next lesson. What way of thinking do I want students to practice today? And a good way to ground yourself as you answer this question is to look at the standards for mathematical practice. What is it there? What actions are you building within your students today, tomorrow, next week? Not what procedure, not what page you're going to be on. What way of thinking? Then decide how you will model it, how students will practice it, how they will explain it, and where they'll be asked to connect it to something they already know. That's guided instruction with purpose. There's one more piece of this conversation, though, that we have to name. If we want students to learn how to think mathematically, teachers have to be trained how to think mathematically first. When we look at the sheer number of standards we're expected to teach in a year, it can feel overwhelming. It can feel like too much content and not enough time. But what often gets overlooked is this. When we honor the connections between ideas, we actually reduce our own cognitive load. We're no longer teaching dozens of isolated skills. We're teaching a smaller set of powerful ideas that show up again and again. But that only happens if we understand those connections ourselves. And that means personal learning is not optional. That means professional learning is not optional. We can't wish to know more. We can't assume experience alone will fill our gaps. We have to seek learning and engage authentically while we're in it. This work requires us to slow down, reflect, and sometimes sit with discomfort as we realize what we were never taught to see. And that's not failure. That's an invitation. If I had it my way, early learning spaces would be more intentional about the proficiency level students leave with. Toddler-facing learning centers and daycares will be designed with purpose so that when students enter school, they're ready for a formal learning environment. And some of you may hear this, and you may say, well, the facility that my child went to, it was great. Like my kid did leave with X, Y, and Z. But there's many students in our classrooms who don't have that experience, who they're going to facilities and they're not doing a lot all day. They're entering kindergarten not knowing a lot of information. And I saw a post on Facebook just the other day where people were battling with the poster, and the post said that parents have to do a better job of teaching their kids basic information before they start school. And some of the people in the comments section were like, that's the school's job. And my response to that is, if you are a parent listening to this and you have friends who are parents, one thing that I want to share with you is that we are the first educators. And if you want your child to truly be successful, you cannot leave that success in nobody else's hands. You have to do what you need to do to make sure that your child is prepared. And this does not mean that you have to go to school for education. The internet is literally filled with videos and resources to help you teach your children what they need to be successful as they enter formal school. So many resources everywhere, right? So you don't have to get a degree in education to set your child up for success. You absolutely do not. And for those facilities that you're going to, if you don't see the change happening, the growth happening, I would ask them a question. I would ask them about the standards that they're following. I would ask them about the expectations. And then I really would hold them accountable for my child growing, because we have to do this together. Because if you're doing what you're doing at home and they're doing what they're doing in the facility, that child should be more than ready by the time they enter kindergarten. That's my 14 cents. Okay. So from there, from those early learning facilities, kindergarten through second grade would focus on maintaining the proficiency that the students came in with. And remember, this is if I had it my way. This is if I had it my way. Because I know you're thinking proficiency, a lot of the students don't come with proficiency. And that's why we have to talk to the learning centers. That's why we have to talk to the parents. So again, kindergarten through second grade would focus on maintaining proficiency and identifying intervention opportunities early and follow through. If you're working with students and you notice that there is something that is atypical, there is something that is out of the norm, don't sweep it under the rug. Don't say, we're not going to worry about this. I'm not going to be the person to do this. I don't want to deal with the paperwork. I don't want to deal with the monitoring. I don't want to insert whatever you've heard people say. Escalate it. Send the referral. Talk to the parents. We have to intervene early if we want children to be successful. Okay? We have to intervene early. Grades 3 through 5 would do the same thing. Maintain proficiency. Identify intervention opportunities, because we know that everybody is not going to act. So we have to be on it. If you're in the 3-5 band, you got to be on it. And then I also want to highlight, and I saw this on TikTok, someone talking about the difference between a student having unfinished learning and students having a disability. Just because a student doesn't understand something or doesn't know something doesn't necessarily mean they need a disability, which is why you want to intervene, which is why you want to follow that MTSS process with that tier 2. And if you need to, the tier 3, so that you can help students fill in their unfinished learning. You can help students get caught up, because it may not be a disability. It may have been they were in the classroom with a substitute. It may have been something happened in their family and they checked out for several months. You just never know, but we have to intervene. And that same mindset of maintaining proficiency and identifying interventions would continue. Every teacher at every level would understand the connections across grade bands. And this is important. This is important. That means the tricks that we teach in our classroom that somebody else is teaching differently. That means the vocabulary that we use in our classroom that somebody may be using differently. We got to let it go. We have to let it go. We need to be one band, one sound. Okay? One math, one sound. We have to have a math pact within our school system, not even just our school, within our school system, so that everybody, no matter where you are, we're talking the same language. Math is a language. We're talking the same language. So that means if a student stays at your school or stays in your district through 12th grade, they're good. They're hearing the same thing over and over again. They're building a deeper understanding. But if they move from your school and go somewhere else, they should be able to get the same experience. They should be able to hear vocabulary that is accurate, that is academic, that prepares them for what they may see in a subsequent grade level, what they may see on an assessment, what they may see in a task, what they may hear in conversation, what they may experience when they go into their career. We need to use it. We need to use it. So we also have to leverage those connections to provide students with deep, meaningful experiences instead of disconnected ones. Let's stop letting the math live on islands. Okay, that's my dream. That's if I had it my way. And the reality is we are years away from that vision becoming systemic unless something changes. A lot of what impacts classrooms is out of our hands. Policies, pacing guides, testing pressures, but so much of it is still in our hands. We can choose to shift from commitment to complaining to commitment to changing. That shift might look like bringing one new idea to your POC meeting, asking one deeper question about why a strategy works, revisiting a representation you haven't used in years or ever, sharing this work with a colleague who's also searching. It can look like being honest about your strengths and your areas of opportunity. It can mean realizing that just because you have a resource in your hand doesn't mean that you're prepared for the lesson. Change doesn't start all at once. It starts when enough people decide that understanding matters more than coverage. And that's why this work can't stay quiet. If this way of thinking resonates with you, I want you to spread it. I want you to talk about it. I want you to share it. I want you to bring it into your planning conversations and your classrooms. Because students don't need us to know everything. The students need us to be willing to do the work to see more so we can help them do the same. This month was about understanding math. It was about slowing down. It was about seeing structure. It was about reasoning before rushing. Next month, we move into connecting math. Those understandings come together through ratios and proportions. If this foundation is solid, students won't feel like they're starting over. They'll feel like continuing a story they already understand. Geometry and number sense are not side topics. I don't care what the test specifications say, what percentage it is. They're not side topics. They are the doorway into a world of limitless possibilities. Same story, next chapter coming up. Talk to you soon.